Okay, continue. Differentiability of a function at point A. So when you have differentiability at a point A, suppose our formula f prime A. Alright, take down the formula using first principle, limit x approaches A, then fx minus fa over x minus A. So in the case of like this, piecewise function, so you need to do your limit from the left hand side and right hand side. If you didn't get your function as piecewise function, you get normal function, just one only, we can directly use this formula. If we get piecewise, then we have to separate left, right. We see whether the limit exists or not. If the limit exists, means your first principle is exists, then your point at A is differentiable. Alright, so with the example number 3 here, they're giving you is a piecewise function. Alright, so piecewise function, we draw in interval less than 1, 3 minus x. More than 1, 2x squared. Firstly, determine whether it is continuous. This is topic 8.3. Then we see how it related to our differentiability, topic 9.1. So we go for topic 8 first, whether it is continuous. Continuous, we check continuity, we have 3 conditions. The first condition will be its point. So what point do we concern here? As you can see at point 1, we have different functions from the left and from the right. So we are concerned about x equals to 1. So therefore, we find for the first one, point 1. Point 1, it is occur at the quadratic here. So point 1 is following the quadratic function. You can see the equal here. So we find out the coordinate. It is 2, where this point it is defined in continuity. Second step, we want to make sure the limit is exists. So to see the limit exists or not, we will going to approaches 1 from the left hand side. Function 3 minus x. So 3 minus 1, it is 2. Then we do limit approaches 1 from the right hand side, which is a quadratic. So it is also equals to 2. From here, we can conclude our limit when x approaches 1 for the function it is 2. It is axis. Why it is axis? Because its limit from the left hand side is equal to the limit from the right hand side. Condition number 3, we have to see whether the point is it same with the limit. So obviously point is value 2, limit also value 2, so the point is equal to the limit of the function. Therefore, we can conclude out this function is continuous at x equals to 1. So that will be our first part questions. Continuity. Okay, so we see the notes here. Have you done? Okay, when I want to continue whether it is differentiable at 9.1, you see the note here. So if you can differentiate at x equals to a, means it is continuous at a. But if you continuous at a, doesn't mean that you can differentiable. Alright? Alright, so now we only have it is continuous at a. But it doesn't mean that it can differentiable. So when you want to do differentiable, you follow back the first principle formula. Okay? So f prime 1. It will be limit x approaches 1 tutup pintu. Okay, so use your first principle formula. Limit x approaches 1, function f1, x minus 1. So do you have this coordinate f1? Your a is 1. Do you have this coordinate f1? You found it already, which is 2. Alright, so this is your first principle. Whether we see it can be differentiable at x equals to 1. So for function part, now we want to substitute function part. Function, left hand side, right hand side, different function. So we need to do limit on the left and limit from the right. Limit from the left, limit from the right. Because function is different. Alright, function, left hand side, 3 minus x. Minus point over x minus 1. Simplify this, we get negative x plus 1. And we want to evaluate this, we get IDF. So we simplify, we take out the negative. And you can see it can be factorized. So limit x approaches 1 from the left hand side, negative 1, we get negative 1. Then we proceed from the right hand side. Right hand side function is 2x squared. So minus 0.2 coordinate x minus 1. We try to evaluate, substitute 1, we get IDF. So when you have IDF number, we simplify by factorize. So 2 take out x squared minus 1. So still can factorize x plus 1, x minus 1 until we can simplify our IDF. Then we evaluate our limit again. 1 plus 1, 2. 2 times 2, 4. So can you see the limit from the left hand side, right hand side? In the first principle, same or not? Not same. So here we can prove again, when you have continuous, it doesn't mean that it can be differentiable. So we still need to apply our first principle formula. Alright, then we do out our conclusion, where limit 1 from the left hand side, function minus coordinate does not same with limit approaches 1 from the right hand side, function minus coordinate does not same, means first principle does not exist. Limit does not exist. Then when our limit does not exist, our f prime 1 also does not exist. Here we can conclude function is not differentiable at x equals to 1.